Today we're going to have a very interesting subject topic. It's on the frontal lobe, and the frontal lobe is the seat of your executive function. This is what makes you human, right? This is what makes you the executive, right? And loss of this is a term called executive dysfunction, meaning doesn't seem to be any purposeful behavior. It's just a lot of doing a lot of things, but nothing really meaningful or nothing really purposeful. You know? That's what executive dysfunction is. So let me go ahead and look here. First, let me see if I can go to here. Okay, let me see if I can go to Grok. Ron, how's it going, buddy? My man, Ron, how you doing? Can you hear me, Ron? How's it going, buddy? Okay, so here, first let me show you a image of the frontal lobe. Here it is. Here's the frontal lobe here in red here. And this prefrontal cortex is still a part of this frontal lobe. You know, here is the temporal lobe here, right? Here's the parietal lobe here. So what we're looking at here, we want to look at the frontal lobe here. Okay? And so let me just here briefly. What does the frontal lobe do? Um, here. The frontal lobe of the brain is vital to human consciousness, as well as functions that appear uniquely human, such as spoken language. Frontal lobe damage can lead to a wide variety of symptoms: memory, judgment, abstract thought, creativity, social appropriateness, motor tasks. The frontal lobes are the most common injury that occur in the brain. Damage can lead to a wide variety of symptoms such as movement difficulties, difficulty speaking, and changes in social behavior. So here's the frontal lobe here. And one of the reasons why it's important to sort of understand this part of the brain is that when you start to see individuals with behavioral problems, like problems with judgment or things like that, problems with insight, problems with organization, you want to think about the frontal lobe. And in cases with frontal lobe hypoactivity, that's usually seen in cases of attention deficit disorder, right? And remember, we place those patients on a stimulant, right? So if they're hyperactive and restless and can't sit down because attention deficit hyperactivity disorder, then why do you put them on a stimulant? Well, you want to stimulate this frontal lobe here. So the stimulant is not for the body, it's to stimulate the frontal lobe. The frontal lobe becomes more active, more dominant, and then the frontal lobe begin to suppress all the activity that you see, the excessive motor activity and things like that that you see in patients with attention deficit hyperactivity disorder. So you can see how important this frontal lobe is, and how important it is to know what the function is. So here, so So explain the function of the frontal lobe. So in this series, remember we looked at the hippocampus and we sort of looked at how those systems were functioning in there. Then we went to the amygdala. I remember that we did the basal ganglia. And remember, in each one of these systems, we want to look at the networking and look at the receptor profiles in here. And hopefully, if we understood the receptors, then we sort of have an idea of what type of medications we want to sort of address issues connected with dysfunction in the frontal lobe. Okay. So here, the frontal lobe, located in the front of the brain, is a critical region responsible for a wide range of higher order cognitive, and behavioral functions. It plays a central role in what makes us uniquely human, including decision making, planning, and personality expression. Below is a concise explanation of its primary functions with deeper reasoning where relevant. Okay, so look at this. So executive function and decision making, right? Motor control, remember ADHD, speech and language production, hyperactivity, that talky, personality and social behavior, attention and working memory, emotional regulation, so all of these are very important roles of the frontal lobe. So executive function and decision making. The frontal lobe, particularly the prefrontal cortex, is responsible for executive functions, which include problem solving, right? Reasoning, right? Planning, right? Decision making. It evaluates options, weighs consequences, and help prioritize actions based upon goals. As you can see, that's a very important function to have. Very important function: problem solving, reasoning, planning, decision making. Okay, here, motor control. The primary motor cortex, located in the posterior part of the frontal lobes along the precentral gyrus, controls voluntary muscle movement. It sends signals to muscles throughout the body to execute precise actions when writing or while walking. So we have the primary motor cortex that's located in the frontal lobe. Controls voluntary muscle movements, So I'm sure you get the stimulants make the frontal lobe more active, so you get more control over the movements. And I guess that's the mechanism of shutting down the hyperactivity seen in attention deficit disorder. Okay, the motor cortex is organized somatotypically. That is the motor homunculus. Remember the homunculus, where specific areas correspond to specific body parts, ensuring coordinated and intentional movements. And so here, this frontal lobe, executive functioning and motor control. Okay, speech and language. Yep, Broca's areas. Yeah, typically, it's been a while since I've pronounced Broca's areas. I even thought about this. Broca's areas, typically located in the left frontal lobe, is crucial for speech production and language production. It coordinates the muscles involved in speaking and helps form coherent sentences. It helps coordinate the muscles involved in speaking and helps form coherent sentences. Broca's area. Remember, Broca's aphasia. When we have, Broca's area, Broca's aphasia. Okay, yeah, damage to this area can result in Broca's aphasia, where individuals struggle to produce fluent speech, but still may understand language. So they can receive the information, but they simply have difficulty with the process of speaking due to the damage. Okay, personality and social behavior. The frontal lobe, especially the orbital frontal cortex, regulates personality traits, emotional responses, and social behaviors. It helps us interpret social cues, inhibit inappropriate actions, and exhibit empathy. For instance, it prevents impulsive or socially unacceptable behaviors like shouting in a quiet setting by assessing context and consequences. That makes sense. Okay. Attention and working memory. Yeah, for attention deficit disorder, right? The frontal lobe helps maintain focus and damage working memory and manage. The frontal lobe helps maintain focus and manage working memory, the ability to hold and manipulate information temporarily. Yeah. It filters distractions and sustain attentions on task, which is why frontal lobe dysfunction is also linked to conditions such as ADHD. Yeah, like we said before, uh, attention and working memory. This is significant. Yeah, because I thought part of the working memory was also in the prefrontal cortex also. So I can see the attention and working memory, social behaviors, Broca's aphasia, motor control, ADHD, of course, executive dysfunction. Um, so here, emotional regulation. The prefrontal cortex interacts with the limbic system. I can imagine, yeah, yeah, to modulate emotions. To modulate emotion. It helps balance emotional impulses with rational thoughts, enabling us to stay calm under stress or delay gratification. For example, choosing to study instead of watching TV involves the frontal lobe suppressing immediate desires for a long term goal. Yeah, yeah. For example, choosing to study instead of watching TV involves the frontal lobe suppressing immediate desires for long term goals. Huh, amazing. The frontal lobe is one of the last brain regions to fully mature. Yeah. Not often until the mid 20s, which explains why adolescents may struggle with impulse control or long term planning. Yeah. Why they need so much support and structure. Damage to the frontal lobes via trauma, strokes, or neurodegenerative diseases can lead to impairment in poor decision making, apathy, or disinhibition, depending on the affected subregions. Yeah, we see that a lot in diffuse traumatic brain injuries and things like that, damage to the frontal lobe. You see the impulsivity, the agitation, combativeness, aggressiveness, the unpredictable nature of it all. Um, yeah, its connectivity with other brain regions like the limbic system and the parietal lobe allows it to integrate sensory, emotional, and cognitive information for cohesive behavioral experience. And so this is really interesting on the frontal lobe here. Um, so also, let me see if it can explain the networks going through the frontal lobe. Can explain the operating frontal lobe. The frontal parietal network, the default node network, the Salence network. Yep. I'm not sure if this is going to be what you guys are interested in as medical students, things like that. Oh, it's giving all the networks. Okay, here, the frontal lobe is integral to multiple neural networks, each specialized for distinct functions. The FPN for cognitive control, the DNV for self reflection, the SN for salience detections, CON for sustained attention, the frontal striatal for reward and habit, motor network for movement, and language network for speech. I wanted to point out that they did go through the process of sort of labeling these huge networks that sort of helps these lobes function like this. So let me just go through a few of them just to show you, but not too much. This frontal parietal network. Um, it is critical for high levels of cognitive functioning, including working memory, problem solving, planning, and cognitive control. Okay, look at this. Oh, how it works. The FPN integrates information from sensory and memory systems to guide goal-directed behavior. Okay, and the default mode network, it involves the DMV is involved in internally focused process such as self-reflection, mind wandering, autobiographical memory, and image future scenarios. And so I just wanted to show you that. Didn't want to get too deep into it, but also let me go through and see if they can describe the receptor profiles. The receptor profiles in the frontal lobe. And remember, we covered the amygdala yesterday. And remember, we're looking at the different receptors. I'm sure it's the same group of receptors: glutamate, GABA, dopamine, right? Serotonin, norepinephrine. The frontal lobe, a critical region for cognitive, emotional, and motor, right? So cognitive, emotional, motor functions contain a diverse array of neurotransmitter receptors that mediate neuronal communications and modulate network activity. These receptor profiles determine how neurons in the frontal lobe respond to neurotransmitters, right? Drugs and other signaling molecules influencing the function, right? So we want to look at the receptors. And so at least if you understand the receptors in this region, at least you understand what medications you can reach for. Remember, so we have our glutamate receptors. You know, we have one of the medications I use to target glutamate is Namenda. And so it decreases glutaminergic activity. That's very helpful in patients I use with agitation. We have GABA receptors, typically benzodiazepines, right? We can use to sort of help with any agitation or combativeness there. And remember, for glutamate and GABA, these are the main. Glutamate is the main excitatory neurotransmitter. GABA is the main inhibitory neurotransmitter. And you want to get balance between both. Remember, the major mood stabilizers like Depakote and lithium results in down regulation of glutamate receptors and upregulation of GABA receptor. So remember, with chronic agitation, combativeness, maybe head injuries, with impulsivities, restlessness, and things like that, you really want to make sure that you can use your mood stabilizers to target both the glutamate here and the GABA receptors all in one here. So I think this is one of the reasons why Depakote and lithium are very effective in diffuse traumatic brain injuries, particularly ones that may involve the frontal lobe. So here are glutamate receptors, GABA receptors. So GABA, the major mood stabilizers, and also benzodiazepines, IM benzodiazepines. Okay, now dopamine receptors. Okay, so it has D1 receptors, right? And then it has also D2 receptors, D2-like receptors. Remember, for the typical antipsychotics, they primarily bind D2 receptors, not necessarily D1 receptors. So they have a very high affinity for these receptors. So they bind them very strongly. That's the typical antipsychotics. Now, remember, the atypical antipsychotics also, they bind D1 receptors, D2 receptors, and also serotonin receptors, norepinephrine receptors, either acetylcholine receptors too. So, so in this case, a mood stabilizer can help downregulate glutamate receptors, upregulate GABA receptors. And if it's an urgency, you can use benzodiazepines urgently to target GABA to activate those receptors to get the inhibitory benefits. With a typical antipsychotic, you'll target the D2 receptor here, but you won't target any of the other receptors. If you were to use a atypical antipsychotics, it'll target D1 receptors, D2 receptors, the serotonergic receptors. Some of them target the acetylcholine receptors. So that's why mood stabilizers like Depakote lithium and atypical antipsychotics like Seroquel, Risperdal, Geodon are very helpful in things like diffuse traumatic brain injuries. Does that make sense, guys? Hope so. Let me see here. Let me see if I can get any questions here. I'm here at 20 minutes, and so I didn't want to go too far over 20 minutes. I didn't want these little sessions to be too long, but let me see if I can answer one question. Hey, Mohammed, how's it going, buddy? Thanks for the question, Mohammed. Is the frontal lobe the true seat of free will? I would say absolutely. That's where you decide to turn left or to turn right, and that's the ultimate decisions. Okay. All right, guys, I think that's it for today. I hope that was helpful for you guys. If you have any questions, you can just put them in the comment section. And so this is on the frontal lobe. I hope it's helpful for you guys. Take care, guys. Read out. Ciao. So the name of discussion is mesocortical pathway, and we're going to be talking about schizophrenia, the relationship between schizophrenia and autism. These two processes seem to connect at the level of the mesocortical pathway. So damage to the mesocortical pathway at specific developmental periods can give you an idea of the cluster of symptoms the person would like to experience. Some of the newer research suggests that damages to the mesocortical pathway in the earlier developmental periods of life, like before puberty, those symptoms present as symptoms that we interpret as autism. But when we look at these in the context of schizophrenia, they appear to be more negative symptoms of schizophrenia. After a certain developmental milestones are reached, then damage to that mesocortical pathway can produce hyperactivity that you would notice as prominent positive symptoms, or it could produce like hypoactivity that we recognize as negative symptoms. So the mesocortical pathway is a very important structure to sort of understand. So let me go ahead and look at the mesocortical pathway real quick. Okay, medical pathway here, schizophrenia right here. And I think the last discussion we talked about the mesocortical pathway. Let me just show you here. So here's the mesocortical pathway right here, right? Okay. So damage to this early damage to this pathway can create hyperactivity that we interpret as positive symptoms of schizophrenia. The damage can also create hypoactivity that we commonly refer to as negative symptoms. The hypoactivity can get to a point where we can probably interpret those things, that degree of hypoactivity, severe degrees of hypoactivity, as a form of catatonia, when the person actually can't move and things like that. So this important pathway is very important. Okay, so here, let me look at his. Okay, how about if I say just positive symptoms? So hallucinations and delusions. I think I can find a better. There's the positive symptoms. Let's see here. Okay, positive symptoms. Okay, so look at this. So positive symptoms, okay, let's look at the entire clusters. Delusions, that's what you think. Hallucinations, sensory experiences. disorganized thinking or behavior, that's the organization of your thoughts and how your thoughts flow. So look at the positive symptoms, disturbances in the way you believe things, and disturbances in the sensory experiences, and disturbances how you organize things. So delusions are false beliefs. Two categories: things that are improbable versus things that are impossible. I got kidnapped by aliens, impossible. But it's probable that people were dressed like aliens when you got kidnapped. I'm not saying you're getting kidnapped. I'm saying you got it wrong who you got kidnapped by. Look at these delusions: persecutory, someone's after me; grandiose, referential. Things are very complicated. Referential delusions, hallucinations, auditory, visual, tactile, disorganized thinking. Your frontal lobe and should be able to suppress a lot of unnecessary information or distractions, so that you would be able to focus on one continuous train of thought. And hopefully you should be able to organize those thoughts in a way so the whole system is coherent and so you can comprehend it. In the face of schizophrenia, it seems like the filtering system breaks down and you get everything. And you have to pay close attention to patients who have disorganized thought processes, because they're trying to express something, but the filter's there. You get everything at once. It's just very challenging to make. So those are the positive symptoms of schizophrenia. Let me see, negative symptoms. Okay. Look at this. Negative symptoms: hypoactive mesocortical pathway. So everything is sort of turned down. Blunted affect, right? You don't expand as much. Don't speak as much. Don't move as much. You don't engage as much. You don't experience as much pleasure. It's like everything is turned down. In schizophrenia and the negative symptoms. So look at these symptoms, the negative symptoms, and let's see how they compare with autism, the symptoms of autism. So remember the blunted affect, and isn't it, and then reduced emotional expressions. Isn't that one of the things we say in autism? They have the difficulty connecting socially. The reduced speech, that may or may not happen. Lack of motivation. They're simply not interested in the things that you're interested in. So trying to get them to do something they don't want to do will, definitely show lack of motivation. Social withdrawal, right? Reduced experience of pleasure. I'm not sure if they have that all the time. I think that's probably frequent as in a normal population. So negative symptoms, and let's look at, instead of negative symptoms of schizophrenia, let's put that autism. Okay, look, difficulty with social interactions, avoiding eye contact, and struggling to make friends. Communication challenges include delayed language development. So remember, this mesocortical pathway is damaged very early, primarily before puberty. And so the other structures, things like that, I don't think they grow to the same extent. And because they don't grow, the whole system is more developmentally delayed. All of those networks have to develop themselves independently. They all develop independently. So you can get wide fluctuations in how the quality of how each of these networks work. Communication challenges, right? Language development, difficulty understanding or using verbal cues, repetitive speech patterns, restrictive language, repetitive languages. Look, problems with social interactions, problems with communications, other potential problems, sleep, GI. Okay, so I think you get the point there. Let's see, how long have we been going so far? So far at 15 minutes. I think I'll do the lectures only 20 minutes at a time. Okay. Let me go to, let's see what Google Scholar has to say. Look at this. New therapeutic options for severe autism disorder. Deep brain stimulation of the mesolimbic and mesocortical pathway. If the pathway is damaged, you may have to zap it with some electricity to get the pathway up and running again. So deep brain stimulation, I'm sure the deep brain, the device could probably recognize the frequency at which the network is working, and it can probably sort of reset the network by firing itself. That's interesting. It's interesting. I'd like to see how that looks like. Okay, recognizing the circuitry underlying cerebellar, mesocortical pathway damage, cognition, apathy, and gait. Cognition, apathy, gait. Negative symptoms of that is autism again. Dopamine dysregulation, autism spectrum disorder. Let me see this. Mesocortical pathway damage and cognition, apathy, gait, and cerebral small vessel disease. Many times I find that I always stay here on Google Scholar, and I subscribe to a lot of the main journals. I don't have it on this computer. But it helps me really put my treatment of the patients in context. Sometimes the textbooks or the learning materials may be very difficult. Maybe difficult for me to digest, but coming here to the actual studies themselves are very useful. In conclusion, our study showed that 3 clinical features, cognitive impairment, apathy, and gait dysfunction, of that is strongly interrelated with the damage to the mesocortical pathway and could be a common neural basis of the 3 features. Okay, what is, that's small vessel disease. Yeah, we do see that in small vessel disease. Okay. That's it with that. See if there's anything else interesting here. Autism and dopamine. Dopamine-mediated mesocortical dopamine release influence the mesocortical pathway. And I don't want to get into that. So right now we're at 18 minutes. And so let me see if I can take a few questions to see if you have any questions. So the point here is for the students who are rounding with me, that mesocortical pathway is very important. And we see the positive symptoms of psychosis. And when it's very severe, we have to go to the typical antipsychotics like Haldol and Thorazine, because those typical antipsychotics are potent enough to sort of manage the instability in this network. Any questions, though? Let me see if I have any questions. Here, I have one question here. Is the mesocortical pathway something we can strengthen or repair? That's advanced. I mean, I can imagine developing implants, maybe a coupler or something like that wraps around the main trunk of the mesocortical pathway, and with radio waves, that picks up the frequency and things like that. And then maybe you can modulate your mesocortical pathway. I think we're coming into something like that. Yeah, I think it's going to happen real soon too. So yes, I think right now I don't think we don't have the technology to strengthen or repair. We just manipulate the neuron by targeting the receptors. Basically, this neuron in many cases is hyperactive, and we block the receptors to slow it down. Okay, next question is here. Is it possible for someone to be misdiagnosed with one and then they actually have the other, or both? Remember, the DSM-4 focuses on the symptomatology, and it's very difficult learning to identify specific disorders with symptomatology that's present throughout all of the different disorders. And then you have to find a certain cluster at the same time over a period of time in order to make a diagnosis, and that's very complicated. So I think our language and our terminology comes from that pursuit to try to gather the symptoms and come up deductive reasoning, I guess. But since we understand the functionality of the mesocortical pathway, I think my emphasis in my career is to sort of focus on the functionality of the pathway and see if I could master manipulating it with the tools that I have. So is it possible for someone to be misdiagnosed? Yep, all the time. One of the things I do is I try to use standard scales like the brief psychotic rating scale, the Young Mania rating scale. for mania, the confusion assessment method for delirium, the things like the CIWA for alcohol, CALS, clinical opioid withdrawal scale. So I use a lot of scales to sort of try to quantify the severity of the disorder, and at least I have some type of parameters. Okay, great. Let me know if there's any other questions here. If there are not any other questions, then it's at 21 minutes, and I know the students don't like to wait around for long. So I'll go ahead and end this. Okay, I do have another question. What's the difference between this and the mesolimbic pathway? Two different pathways. This is the one that connects your lower brain, your midbrain, your prefrontal cortex, and then your frontal lobe. And so this is covering that territory on those different lobes right here. This is your mesolimbic, okay, and that's your limbic system, this reward pathway. This is the target of a lot of the targets for substance abuse and everything. We'll make this pathway hyperactive, get a high. It's low, you withdraw. So these are two distinct pathways, and they serve completely different functions. Okay, here, great. Does trauma affect the mystical cortical pathway? Oh my God, listen, narcissists, psychopaths, and sociopaths seem to have an innate predilection for this pathway, because it seems to me that the cognitive, emotional, and very soft neuropsychiatric manifestations of emotional and psychological abuse tend to manifest themselves in dysfunction in this pathway. So you're being abused, you can't remember things, you can't organize things, you're very forgetful, your mood is very labile, very can be unpredictable, it can be impulsive, your sleep can be disturbed. And it seems like these sociopaths, they focus on all the emotional, psychological stress that will damage this. And in fact, if certain hormones like the stress hormone, cortisol, adrenaline, all those, they tend to increase expression of glutamate, and glutamate turns everything on, and then the cells start popping. The cells, the area that's overly stimulated, start to experience a death in the nerves in that area, and so the person starts to show cognitive and neurocognitive deficits because of the hormonal and neurotransmitter imbalance and how much stress they're under. So patients with like chronic PTSD typically have very severe memory problems due to the impact of the hormones and the neurotransmitters on excessive amounts on the actual physical function and networks of the brain. Let's see. Any other questions, guys? Any other questions? Okay, so we're at 25 minutes. If there's no other questions, then I'll go ahead and end this stream for now, and we can talk about this tomorrow if you have any other questions, okay? It's a pleasure talking to you guys, and read out. I'll see you tomorrow. Ciao, guys. Hey guys, how's it going? Reed here. I didn't realize I was live, but here making some coffee, make some tea. How's it going? Today we're going to go over serotonin receptors. Serotonin is very important. Very important. Every time I think of the new neurotransmitters, it seems like when they're in excess, they present with a certain type of symptoms, a certain symptomatology, a certain patterns, And when the same neurotransmitters are diminished, they present with another presentation and more of the withdrawn phase of that disorder, right? So remember with dopamine, excessive dopamine, right? Um, Psychoticism, delusions, and sometimes delusions are very uncomfortable to think about, And when excessive dopamine, you sort of think about a horror story, right? Excessive dopamine sounds like a horror movie, right? And excessive norepinephrine is more like when you hear at the end of the Super Bowl, right when they win the Super Bowl, hey, 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 where you going after the Super Bowl? I'm going to Disney World, right? That's like what I sort of like think about stories when there's excessive amounts of norepinephrine, and then I start thinking things like mania, right? Mania, you know. Um, and again, it may not even be mania. It may be that the person is simply mismatched with the environment at the time. And the people who are slow are referring it to as mania because it makes them feel better. But when you think about excessive norepinephrine, think about mania, you know. And then here we're going to do the one on serotonin, excessive serotonin, love, things like that, right? Affection and things like that, falling in love, you know, the sense of warmness, sense of oneness, unity. And of course, low level of serotonin, depression, and anxiety, right? So we're going to go over the serotonin receptor. Um, and let's see here. So I have here. Okay, let me see here. Or is this one better? This one's bigger. That's big. Good. Okay, how about this one? Okay, so this is just a free grok, and you can use anyone you want. Explain serotonin receptors. Okay, let's see what we get here. I hope I'm connected. Let me turn a little music off here. Okay, let's see. Explain serotonin receptor. Look, distribution here. Serotonin receptors are found in the central nervous system, the brain and spinal cord. Also in the peripheral nervous system, other tissues like the gut. Remember, you give SSRIs and things like that, they can have like GI upset right there. Blood vessels, remember lightheadedness, dizziness, hypotension. It can cause those as side effects. Changes in your cardiac arrhythmia, things like that. Okay, the various locations explain, the various locations explain serotonin's wide range effects. Okay, so that's why this is the distribution to other tissues is one of the reasons why you get side effects and why they present the way they do. So whenever I give patients with these SSRIs, watch out for any lightheadedness, nausea, vomiting, or dizziness, things like that. So let's get into it. Okay, so serotonin receptors are a group of proteins found on cell surfaces that bind to serotonin, right? 5-hydroxytryptamine, okay, or 5-HT. The neurotransmitter involved in regulating, mood, sleep, appetite, memory, and other physiological processes. Remember appetite. Remember, these receptors are responsible for these like domains of functions, just like mood, right, sleep, like appetite, like memory, and other physiological processes like weight gain and things like that, energy level, interest, and things like that. But isn't this all of the symptoms of depression, right? When you ask someone about depression, don't you ask about mood? Yeah, how are you sleeping? I'm not sleeping well. I can't fall asleep, or it takes too long to fall asleep, or I'm sleeping too much and really tired. Memory, hey, it's impacting my memory. I can't think about things, and other physiological processes like weight loss or weight gain, things like that. So you can see the symptoms of the SIGI caps. I guess the symptoms of depression are basically attached to the domains of things that this receptor is responsible for. So these receptors are critical for maintaining serotonin's effects on the body and brain, right? Okay. There are 7 main families of serotonin receptors, H1 through 7, with multiple subtypes, H5HT1A, 5HT2B, things like this, making at least a total of 14 known receptors. Right, okay, so there's at least a total of 14 known serotonin receptors. Okay, each play a distinct role in location, distinct role. Then they're located at certain locations, and then they have slightly different mechanisms. So I don't want to go into the details of this, but let me just go through the distribution here. So these at 5-HT1 receptors are generally inhibitory, right, and reduces neuronal activity. Okay, look at this one. I think it's 518, which is the other one. Yep, okay, 5 right here. And 5-HT5 receptors are also inhibitory. So the inhibitory receptors, if I can remember correctly, HT1 and 5. So these are all inhibitory, and they decrease neuronal activity. Less understood, but likely inhibitory. Okay. Now, the H2, the other receptors, excitatory, increase neuronal activity, causing the fast excitatory response. Okay. 4, stimulatory, enhances GI cognitive motility and cognitive function. Excitatory. 5, inhibitory. And I think the 6 is excitatory too. Yeah, I'm not sure about this one. 7, excitatory. So remember, 14 total receptors. 2 categories, 1 and 5 are like inhibitory. The other ones are sort of excitatory. And so if you're thinking about if someone presents with depression, a significant amount of anxiety, sort of think about these serotonergic networks being somewhat hypoactive, right? And so we'll need to sort of activate these networks, and so they're more active and we get more transmission. If we get more transmission across these networks, then the lobe is carrying out its responsibility better, right? Okay, so here, those are the 2 types. Okay, so remember we were same thing with the receptors and the networks and the proteins, all that. 2 types, the ion gated channels, and then the G protein channels, the ionotropic and metabotropic sort of pathways. Here it is here. The duality presents right here also, because you see the G protein receptors and ligand gated ion channels. So G protein receptors, most serotonin receptors, 3 are G protein receptors, right? So remember, around 14 of these receptors, at least 14 of the receptors. Most of the serotonin receptors, except 3, are G proteins, which trigger intracellular signaling pathways, including cyclic AMP or calcium release when serotonin binds, meaning it alters the cell functioning. This is very important because remember the ion-gated channels are more are important in the signal in getting initiating the action potential and that form of communication that almost happens instantly. But then the G protein is a possible. This is the process that allows the signal transduction pathway, and that's where we're going to actually create a specific message for the cell body to produce a product. And when it says altering gene function, when the serotonin binds to the receptor, it goes through the signal transduction pathway and produces a product that's then exported from the cell. Then that's when you get an alteration in cell function. Ligand-gated channels, these allow rapid inflow of sodium across the membrane, calling immediate and neuronal excitation. So here, okay. The physiological and clinical relevance, mood and mental health. 5, 1, and 2 are receptors are key targets for antidepressants. Okay, 5-HT1A, 5-HT1-2, they increase serotonin availability, right? Great. 3 and 4, GI. Okay, 6 and 7, neurological disorders. Many drugs, including psychedelics, migraine medications, sumatriptans, and antiemetics, target specific serotonergic receptors. Makes sense. Okay, distribution. Oh, we got through that pretty fast. Okay, and let me see if you have any questions now. Just ask any questions if you have it. So this is for the serotonin receptor. Okay. Let me look at the serotonin molecule. I will see if it can do that. I won't be able to go through this. I remember organic chemistry. Okay, let me see here. Even if I read this, I wouldn't understand it. so let me move on. It's so disconnected from what I do. I was hoping. Let me see if I can find a image of this serotonin. Okay, maybe this is the source. Okay. All right. Serotonin is also known as 5-hydroxytryptamine. Has a molecular formula here. Features 5. Okay. Yeah. This is okay. Yeah. Let me skip that too. Okay. Let me review the SSRI medications. Okay, I don't know if that's I meant SSRI. Okay. Okay, so we use SSRIs for the primary treatment for major depressive disorder, depressions, and anxieties. And it's believed that it's hypoactivity in these networks. And so we use a category of medications called selective serotonin reuptake inhibitors. These basically turn off the reuptake pump that's located on the presynaptic cell. When you don't get as much reuptake of the serotonin from the synaptic cleft into the cell, then more of the serotonin, the tighter increases in the synaptic cleft, and the larger the titer, then hopefully we can increase the transmission. So that's the thought behind it. There are class of antidepressants that work primarily by blocking serotonin transporters, which increase serotonergic level in the synaptic cleft, enhancing serotonergic transmission. This mechanism helps alleviate the symptoms of a major depressive disorder, anxiety disorder, OCD, PTSD, and other conditions. SSRIs are considered a first-line treatment for depression due to their efficacy, relatively favorable side effect profile, and lower toxicity compared to tricyclic antidepressants and MAOs. Mechanism here. SSRIs selectively inhibit serotonin reuptake with a minimal effect on other neurotransmitters, reducing side effects compared to less selective drugs. They primarily interact with serotonin receptors indirectly by increasing available serotonin, which then activates receptors like the 5-HT1A and the 5-HT2A. Okay, so it's approved for major depression, generalized anxiety disorder, social anxiety disorder, panic disorders, OCD, PTSD, and also premenstrual dysphoric disorder. Side effects: lightheadedness, nausea, vomiting, dizziness, some sexual dysfunction, decreased libido, possible weight gain, typical side effect profile. But look, side effects. SSRIs different half-life. A metabolism is via the cytochrome P450 system, mainly the 2D6 and the 3,4-A pathways, and drugs, and interacts with potential drugs. Yeah, see, Prozac has the longest half-life, is days to week. They even have a tablet like called Prozac Weekly. You take once or more. There's some versions that have a half-life less than 24 hours. Okay, so here's another thing that you may want to find interesting here. This is a list of SSRIs ordered by potency, right? The strongest ones first. Because if you're in an outpatient setting, if you have someone with like a major depressive disorder, but it doesn't seem to be maybe on the mild to moderate spectrum, then you want to use the less potent ones. And for the ones that may experience treatment refractory or things like that, or if their depression is mediated by something other than serotonin, then you may want to go with one of these stronger, more potent SSRIs. So here, Paxil, I mean, this is really Paxil is very good medication. It works very well. It's a very potent medication. We give it at night because it can lead to some sedation and dry mouth. It's used for major depressive disorders, OCD, particularly OCD, and PTSD and things like that. 60 milligrams a day, half-life less than 21 hours. Yeah, you have to prepare your patients with Paxil too, because it can cause a lot of anxiety when you're starting it. Zoloft. Okay, here's the Ki. The affinity here is 0.13, 0.29. I don't know what that is. Okay, then we have Celexa, right? Escitalopram, Lexapro right here. Fluoxetine, Prozac, Luvox, citalopram, Celexa, one of the weakest ones, right? Paxil, one of the strongest. So look, Paxil, Zoloft, Lexapro, Prozac, Zolin. Well, now the atypical. Well, let me look at the atypical things later. And I think that's all I wanted to do for now. We went over the serotonin receptor, tried to go through the molecules, diagnosis. I think that's it for now. Okay, guys, I think that's all I'm going to do for today. I'll leave it there. We're at 20 minutes. I don't want to go too far over 20 minutes. But if you have any questions for me, please leave them in the comment section. And please like, subscribe, and share. Read out. It's been a pleasure, guys. Take care. Ciao.